Good morning, students. Today I am going to give some more methods useful in dealing the limits. Next method is rationalization method. Otherwise, rationalizing method. Method of rationalization or rationalizing method. By rationalizing the given irrational part of the given function, you can evaluate the limit. So, based on this let us consider a problem. Find limit x goes to 0 x by root over x plus 4 minus 2. Find limit x goes to 0 x by root over x plus 4 minus 2. Once you put x equal to 0 in this limit, you get 0 by root 4 minus 2, which is 0 by 2 minus 2, that is 0 by 0, which is indeterminate form to us. So, to avoid this indeterminate form, try to rationalize the denominator here, because the rationalize is irrational part here. Try to rationalize the denominator and then evaluate the limit. That is the procedure here. So, limit x goes to 0 x by root over x plus 4 minus 2 is limit x goes to 0. Rationalizing the denominator, we get x into root over x plus 4 plus 2 by root over x plus 4 minus 2 into root over x plus 4 plus 2. Here the rationalizing factor of the denominator is clearly root x plus 4 plus 2. Multiply the numerator and denominator with that rationalizing factor. The rationalizing factor of the denominator is clearly root over x plus 4 plus 2. Just I am multiplying the numerator and denominator with that factor to rationalize the denominator. So, this limit takes the form x into root x plus 4 plus 2 by, on multiplication of these two factors, we get x plus 4 minus 4, a minus b into a plus b. A minus b into a plus b is a square minus b square. So, this plus 4 minus 4 cancel. In the denominator, we get only x. This x and x also cancel. The total limit takes the form limit as x goes to 0. Here x and x cancel. We get only root x plus 4 plus 2. So, by direct substitution here, we get root over 0 plus 4 plus 2, which gives us 2 plus 2, that is 4, a finite value. So, to avoid 0 by 0 form, rationalize the denominator here and cancel this x. You get the limit, the required limit as a finite value. So, this process is known as rationalizing process. By rationalizing the denominator, you can able to avoid the indeterminate form 0 by 0 here. This method is known as rationalizing method. One more problem. Similarly, limit x goes to minus 1, x plus 1 by square root of x square plus 3 minus 2. Find the limit as x goes to minus 1, x plus 1 by root over x square plus 3 minus 2. Clearly this is also once you, as x is nearing to minus 1, this is clearly 0 because minus 1 plus 1 0. And it is minus 1 square. Minus 1 square means 1. 1 plus 3, 4. 4 under root gives us 2. 2 minus 2, 0. So clearly it takes 0 by 0 form, an indeterminate form. In such case, try to rationalize the denominator here. To avoid that indeterminate form, go through the rationalizing procedure. So limit as x goes to minus 1, x plus 1 by root over x square plus 3 minus 2 equal to limit as x goes to minus 1, x plus 1 into, this is x plus 1 into, I will write here, this is limit x goes to minus 1. Rationalizing the denominator, we get square root of x square plus 3. The rationalizing factor of the denominator is clearly root over x square plus 3 plus 2. Multiplying the numerator and denominator with that rationalizing factor. X square plus 3 minus 2 into root over x square plus 3 plus 2. Okay. By rationalizing the denominator, the limit takes that form. So that this is limit as x goes to minus 1, x plus 1 into root over x square plus 3 plus 2 by, in the denominator, the factors are of the form a plus b into a minus b, a plus b into a minus b, a square minus b square. So that a square means you can remove this irrationality, the square root, minus 2 square. 2 square is 4. Now clearly the denominator becomes limit as x goes to minus 1, x plus 1 into root x square plus 3 plus 2 by, clearly the denominator is x square minus 1, x square minus 1. Now you can factorize the denominator x square minus 1 as x plus 1 into x minus 1. This is limit x goes to minus 1, x plus 1 into root over x square plus 3 plus 2 by x minus 1 into x plus 1. Since there is a common factor to the numerator and denominator, you have to remove that common factor in the numerator and denominator. So you remove this one, x plus 1 get cancelled. Now by direct substitution method, the required limit takes the value minus 1 square plus 3 plus 2 by minus 1, which is 4 under root 2 plus 2 by minus 2. 4 by minus 2, which gives us minus 2. The required limit is minus 2. In certain cases, You take one more problem here on rationalization method. Limit x goes to 4, 3 minus root 5 plus x by x minus 4. Limit x goes to 4, 3 minus root over 5 plus x by x minus 4. This is also as x goes to 4, clearly this is 3. 5 plus 4 gives us 9, root over 9 gives us 3, 3 minus 3, 0, by 4 minus 4, 0. Again it takes the form 0 by 0. So to avoid that indeterminate form, try to rationalize the numerator. So the given limit is here. By rationalizing the numerator, we get 3 minus root 5 plus x into 3 plus root 5 plus x by x minus 4 into 3 plus root 5 plus x. The given limit, once you rationalize the numerator here, the rationalizing factor of the numerator is 3 plus root over 5 plus x. So multiply the numerator and denominator with that rationalizing factor. Hence the limit takes the form, limit as x goes to 4. Then here the numerator is of the form a plus b into a minus b. So which gives us a square, that means 3 square is 9 minus b square means 5 plus x by x minus 4 into 3 plus root over 5 plus x. Clearly the numerator becomes 9 minus 5, 4 minus x by x minus 4 into 3 plus root over 5 plus x. Now this is a common factor. So you can remove that common factor, you can cancel that common factor minus 1 times. So limit as x goes to 4 minus 1 by 3 plus root 5 plus x is the required limit. Now you can substitute x equal to 4 directly because it gives us a finite value. So minus 1 by 3 plus root 5 plus 4 minus 1 by, this is 3, 3 plus 3, which gives us minus 1 by 6. The required limit by rationalizing is minus 1 by 6. This is the rationalizing procedure. Whenever you need rationalizing procedure, you have to rationalize and remove the common factors in the numerator and denominator and then apply the limit by direct substitution method. That is the procedure of rationalizing procedure. Now in certain cases, you can straight away apply the formulas also. Instead of going through the rationalizing procedure, you can apply the formulas. For example, let us consider this limit. Limit x goes to 0, cubed root of 1 plus x minus cubed root of 1 minus x by x. Limit as x goes to 0, cubed root of 1 plus x minus cubed root of 1 minus x by x. Actually, it is difficult to rationalize this numerator. Of course, you can rationalize the numerator, but it is a little bit burden on our part to rationalize the numerator. Instead of rationalizing this numerator, we can arrange that limit in the form x power n minus a power n by x minus a as x goes to a. By taking suitable transformations of the functions, simple changes of the functions, you can reduce that function to this form as limit x goes to a x power n minus a power n by x minus a, which gives us n into a power n minus 1. How to reduce, think over that one, how to reduce that value to this form. Now, I will write the given limit. Now, I will write the given limit as, to reduce that limit to that form, to that formula, write 1 plus x, cube the root of 1 plus x as 1 plus x whole power 1 by 3. Add and subtract 1 to the numerator. I am taking subtraction of 1 here. 1 means 1 power 1 by 3. And taking the subtraction to 1 minus 6 minus 1 here by x. Minus of minus plus 1. Here I am adding 1, and whereas here I am subtracting 1 to the numerator. So that the function does not changes here, the nature of the function does not changes here, so that the limit may be written as 1 plus x whole power 1 by 3. This 1 may be written as 1 by 3 by x. This is one term plus 1 minus x whole power. Here is also you take 1 power 1 by 3. 1 by 3 minus 1 by this minus to be applicable to the denominator minus x. Now, I am splitting the function as sum of two functions by taking this negative sign to the denominator. So, this is one term and this is another term. Dividing the numerator with the denominator, you can split the total function as sum of two terms. So that here instead of taking minus, that minus is applicable to denominator, and taking plus here, you can express the total function as sum of two terms. Now this is as x goes to 0, 1 plus x whole power 1 by 3 minus 1 power 1 by 3 by this x may be written as 1 plus x minus 1 here. This is the denominator x may be written as 1 plus x minus 1. Here is also I am adding 1 and subtraction of 1. Similarly plus, this may be written as 1 minus x whole power 1 by 3 minus 1 power 1 by 3 by, here is also add 1 and subtract 1 to the denominator. This is one term and this is another term. Now you can clearly observe that as x is nearing to 0, this 1 plus x is nearing to 1. Similarly, as x is nearing to 0, 1 minus x also nearing to 1. So that both the terms, the limit may be applicable to here, otherwise here as x goes to 0 implies 1 plus x goes to 1 and 1 minus x also goes to 1. Instead of taking x goes to 0, you can take 1 plus x goes to 1 in the first term, 1 minus x goes to 1 in the second term. So that the given limit may be written as limit as x 1 plus x goes to 1. Instead of taking x goes to 0, I am taking 1 plus x goes to 1, because as x is nearing to 0, 1 plus x is nearing to 1 itself. 1 plus x whole power 1 by 3 minus 1 power 1 by 3 by 1 plus x minus 1. This is one limit, plus the other limit is limit 1 minus x goes to 1. As x is 0, 1 minus x is 1. Hence, you can take 1 minus x goes to 1 in the second limit. 1 minus x whole power 1 by 3 minus 1 power 1 by 3 by 1 minus x minus 1. So that both the limits reduces to the form limit as capital X goes to a, capital X power 1 by 3 minus a power 1 by 3 by as x goes to a, x minus a. So both the limits takes that formula x power n minus a power n by x minus a as x goes to a form. Hence, the first limit takes the value 1 by 3 into 1 power 1 by 3 minus 1. The second limit also takes the value 1 by 3 into 1 power 1 by 3 minus 1. Since just that is limit as x goes to capital X goes to a, x power n minus a power n by x minus a is n into a power n minus 1. Based on this formula, you can write n as 1 by 3, a as 1, x is here 1 plus x, whereas here 1 minus x. So that the limit value is here 1 by 3 plus 1 by 3, totally 2 by 3. So the required limit is 2 by 3. So by suitable operations, by taking simple operations, that means by adding 1 and subtraction of 1 in the numerator and denominator respectively, ultimately the given limit is reduced to this form, to this formula, and you can apply that formula to the limit to get the required value of the limit. That is the procedure here. Just a simple and skillful organization of terms in the numerator and denominator and making that limit to the required formula, reducing that limit to the required formula, and you can evaluate the limit with the help of that formula. That is the procedure that you can evaluate. Actually, this problem seems to be it comes under rationalization procedure, but the rationalization procedure is a little bit burdensome to us. Once instead of 3, suppose if you have 5 also, you can apply this procedure, or 10 also. Here once you have 10 also, you can apply this procedure. Whatever may be the power here, you can apply the same procedure. So you can generalize this procedure. You take it as a formula here. Limit as x goes to 0, nth root of a plus x, nth root of a plus x minus nth root of a minus x by x, where n being a positive integer, nth root of a plus x minus nth root of a minus x by x may be written as 2 by n into a power 1 by n minus 1, or 2 by n a power 1 minus 1 by n. This is our formula. In case of in case of evaluation of such limits, you can apply this formula, because here a is 1, clearly a is 1. This term is same. So it is the total term that we get twice. So 2 by 3 multiplied by a power 1 by 3 minus 1 by n minus 1, because instead of 3 here we have n. So that you can use this one as a formula. Keeping that formula in your mind, you can develop such limits. That is also one useful formula to us, exclusively to evaluate such limits. For example, find limit as x goes to 0. Fifth root of 2 plus x minus fifth root of 2 minus x by sin x. Fifth root of 2 plus x minus fifth root of 2 minus x by sin x. As x goes to 0 straight away, it takes indeterminate form, 0 by 0 form. You can observe that one. So, to avoid that 0 by 0 form, you have to modify the given function and reduce that function to the known formula, any known formulas. For that, I will take like this, limit as x goes to 0. This is fifth root of 2 plus x minus fifth root of 2 minus x by x. Just I am dividing the numerator with x. So, divide the denominator with x also. Dividing the numerator with x and dividing the denominator with x. Dividing the numerator and denominator with the same function. There is no change in the function. So, without changing the nature of the function, you can manipulate the function. So that clearly the numerator takes in this form, this formula form. Here a equal to 2, n is 5. So, you can apply the limit to the numerator and you can apply the limit to the denominator separately, because the numerator limit is limit as x goes to 0, fifth root of 2 plus x minus fifth root of 2 minus x by x, and limit x goes to 0, sin x by x, where x is measured in radians clearly. X is real, hence it is a radian. So that the numerator comes to this formula, nth root of a plus x minus nth root of a minus x by x as x goes to 0. That should be observed. So, as x is nearing to 0, nth root of a plus x minus nth root of a minus x by x is 2 by n. That is 2 by 5, n equal to 5. And what is a? A is 2. 2 power 1 by 5 minus 1 by limit as x goes to 0, sin x by x is clearly 1. Both are known formulas to us. So, both are taking a finite value. Hence, the limit takes a finite value. Hence, this is 2 by 5 into 2 power minus 4 by 5. 1 by 5 minus 1 gives us minus 4 by 5. So, the required limit is 2 by 5 into 2 power 4 by 5, or this is 2 power 1 minus 4 by 5 itself, rising to the numerator 2 power 1 minus 4 by 5, collecting the power, same, bases are same. So, that 2 power 1 minus 4 by 5, that gives us fifth root of 2 by 5. 2 power 1 by 5, this is by 5, which is nothing but fifth root of 2. Fifth root of 2 by 5 is the required limit. So, you can use this formula to evaluate such limits. Especially to deal the limits of irrational functions, this is useful formula. This is one useful formula. Similarly, find the limit as x goes to 0. 1 plus x whole power 1 by m minus 1 minus x whole power 1 by m by Similarly, in the denominator 1 plus x whole power 1 by n minus 1 minus x whole power 1 by n. Here is also it is difficult to rationalize the functions. But as x goes to 0, this is 1 and this is also 1 clearly, 1 minus 1, 0. The denominator is also 1 minus 1, 0, 0 by 0 form. It takes indeterminate form once you put x equal to 0 straight away. So, to avoid that indeterminate form, you can reduce this to the previous problem form. The given limit is limit 1 plus x whole power 1 by m minus 1 minus x whole power 1 by m by x, dividing the numerator with x. Similarly, dividing the denominator with x, 1 minus x whole power 1 by n by x. Simply dividing the numerator and denominator with same x. No change in the nature of the function. So now apply the limit to the numerator and denominator individually. This is 1 plus x whole power 1 by m is mth root of 1 plus x minus similarly mth root of 1 minus x by x is our numerator. By applying the limit to the denominator, we get nth root of 1 plus x minus nth root of 1 minus x by x itself. So, both are comes under the previous formula. So, clearly this is 2 by m because a equal to 1, 1 power of course 1 by m minus 1 by, similarly this is 2 by n, 1 power 1 by n minus 1, 1 power the value is 1. So, hence it is 2 by m by 2 by n, which is 2 by m into n by 2. That gives us the limit as n by m. In such cases, you can apply that formula. This is also a very good problem. Limit as x goes to 1, sigma k equal to 1 to 200 x power k minus 200 by x minus 1. That is also a nice problem. Very useful, such problems are very useful to objective examinations. Limit as x goes to 1, sigma k equal to 1 to 200 x power k minus 200 by x minus 1. So, the given limit is straight away this is limit as x goes to 1, expanding the summation. As k equal to 1 we get x, as k equal to 2 we get x square, like that until we get x power 200 minus 200 by x minus 1. This is our given limit. On expansion of this summation we get x plus x square plus x cube and so on until x power 200. As x goes to 1, as x is nearing to 1, it is 1, everything is 1. So, 1 plus 1 is until 200 times. So, 200 minus 200, 0 by 1 minus 1, 0, 0 by 0. Clearly, which takes the form 0 by 0, indeterminate form. So, how to think, how to avoid that indeterminate form here? To avoid that indeterminate form, I will write the limit as x goes to 1 here. Take x, out of 200 take 1 and add to this one. X minus 1, I am taking 1 from 200. Another one is attached to x square. Another one attached to x cube. Like that. For x power 200, you can attach one more one. 1, 1, 1 until 200 times. Here we have 200 terms. For each term, I am attaching 1 out of 200. So, the total limit may be expressed as the limit x goes to 1, x minus 1 plus x square minus 1 by x square minus 1 plus x cube minus 1, and like that x power 200 minus 1. Now, this limit may be expressed as, divide each term with the denominator, x minus 1 here, x square minus 1 square by x minus 1 here, x cube minus 1 cube by x minus 1 here. Like that, you can write each and every term. X power 200, this one may be expressed as 1 power 200 by x minus. Dividing each and every term with denominator, we get this one. Now, clearly, this is clearly 1. So, 1 plus, as limit x goes to 1, x square minus 1 square by x minus 1, x power n minus a power n by x minus a, as x goes to a formula. That is n into a power n minus 1. Here clearly a equal to 1, n is 2. So, 2 into 1 power 2 minus 1. Similarly, here 3 into 1 power 3 minus 1. Like that, here we get 200 n into 1 power 200 minus 1. 1 power 1, 1 square, 1 cube, these are all becomes 1s. So, that we get 1 plus 2 plus 3 plus 4, like that until we get 200. The sum of first 200 natural numbers, based on the sum of first n natural numbers formula, that is n into n plus 1 by 2. That is n into n plus 1 by 2. Here n is 200. So, 200 into 200 plus 1 by 2. 200 by 2 gives us 100 into 201. That is 20100. That is the required limit value, 20,100. Just I applied this formula to each and every term. This is clearly 1 itself. So, you can remove this common factor and you get 1 here, and for remaining terms you can apply this formula to get the limit value. It's a nice problem. That's, you may get such problems in objective pattern examinations. Objective pattern examinations, you may get such problems. In certain cases, you have to simplify the function, and on simplification you may get a common factor, and on cancellation of that common factor in the numerator and denominator, you may evaluate the limit. For such a model, you take this problem. Limit as x goes to 1 by 2. 8x minus 3 by 2x minus 1 This is one term. The other term is minus of 4x square plus 1 by 4x square minus 1. Straight away you cannot apply the limit. Once you take the limit, here we get 4 minus 3 by 0, which is infinity. And taking here is also x equal to 1 by 2, we get 2 by 0. It is also infinity. You get infinity minus infinity form. Infinity minus infinity also an indeterminate form. So this is clearly infinity minus infinity form. Infinity minus infinity form. So which is an indeterminate form. The value of infinity minus infinity cannot be evaluated. So this is infinity minus infinity form. To avoid that indeterminate form, try to simplify the function. Taking LCM and simplify the function. This is 8x minus 3 by 2x minus 1 minus 4x square plus 1 by, the denominator here may be expressed as 2x minus 1 into 2x plus 1. Okay. Now on simplification by taking LCM as 2x minus 1 into 2x plus 1, we get 8x minus 3 into 2x plus 1 minus of 4x square plus 1 as the numerator. The LCM is 2x minus 1 into 2x plus 1 here, 2x minus 1 into 2x plus 1. So taking LCM 2x minus 1 multiplied by 2x plus 1 here. So 2x plus 1 into 8x minus 3 minus 4x minus of 4x square plus 1 is the numerator. This is limit x goes to 1 by 2. Now on simplification the numerator, we get 8 into 2, 16x square plus 8x minus 6x plus 2x minus 3 here minus 4x square minus 1 by 2x minus 1 into 2x plus 1. Now on simplification, we get limit x goes to 1 by 2. 16x square minus 4x square, 12x square here, 2x plus 2x of course, minus 3 minus 1 gives us minus 4 by 2x minus 1 into 2x plus 1. This is on simplification. The given limit reduces to the form. Now this is limit x goes to 1 by 2. Now taking 2 as common, 2 into 6x square plus x minus 2 by 2x minus 1 into 2x plus 1. Now try to find the common factors to the numerator and denominator. Clearly it can be factorized because 6 into minus 2. 6 into minus 2 is minus 12, which may be written as 4 into minus 3. So that this is 2 into limit as x goes to 1 by 2. You can factorize 6x square plus x minus 2 as 4x minus 3 minus 2 by 2x minus 1 into 2x plus 1. Now you can write the numerator as limit as x goes to 1 by 2. The numerator, from the numerator taking minus 1 common here, 3x plus 2, taking 2x as common, we get 3x plus 2. So that 2x plus 1 into 2x minus 1 into 3x plus 1, 3x plus 2 is our numerator by 2x minus 1 into 2x plus 1. So you can factorize the numerator like 2x minus 1 into 3x plus 2. This is the common factor. You can remove that common factor. By removing that common factor, the indeterminate form will arise. So to avoid that indeterminate form, the common factor to be cancelled here. You have to cancel that common factor. Now apply the limit. By applying the limit in the remaining function, we get 3 into 1 by 2 plus 2 by 2 into 1 by 2 plus 1, which gives us a finite value itself. So twice to that of 3 by 2 plus 2, 4 by 3 plus 4, 3 plus 4 is 7, 7 by 2 by 2. These 2 cancel. So the required limit is 7 by 2. So by proper simplification, you may remove the common factor which causes the indeterminate form. By removing that common factor, you can apply the limit and get the limit. That is the procedure here. Next, this is one more interesting problem. Limit as x goes to 0, square root of 4 plus x minus cubed root of 8 plus 3x by x. Limit x goes to 0, limit x goes to 0, root over 4 plus x minus cubed root means whole power 1 by 3, cubed root of 8 plus 3x by x. That should be evaluated. So to evaluate this function, modify the function as limit x goes to 0. Once you put x equal to 0, straight away you get 2 here. Here is also 8 power 1 by 3, 2 cube whole power 1 by 3. This is also 2, 2 minus 2, 0 by 0, 0 by 0 form. So that you have to modify the function. Add and subtract 2 because square root of 2, 4 power 1 by 2 is 2. So, and 8 power 1 by 3 also 2. So add and subtract 2 to the numerator, and you can write the numerator as 4 plus x whole power 1 by 2 minus 2 minus of 8 plus 3x whole power 1 by 3 minus 2 by x. Initially you write the numerator by adding 2 here and subtraction of 2. By adding 2 and subtraction of 2 to the numerator, there is no change in the nature of the function. So without changing the nature of the function, you can take any operation. Now this is 4 plus x whole power 1 by 2 minus this 2 may be written as 4 power 1 by 2, 2 square whole power 1 by 2 by x. I am dividing this total term with x. Similarly, the other one can be written as 8 plus 3x whole power 1 by 3. Here 2 can be written as 8 power 1 by 3 by x. I am taking Here 2 as 8 power 1 by 3. Here this 2 may be expressed as 4 power 1 by 2. Okay. Now, this is, you can split this one as sum of two limits, 4 plus x whole power 1 by 2 minus 4 power 1 by 2. This x may be written as 4 plus x minus 4. This is one limit, minus limit as x goes to 0. This is 8 plus 3x whole power 1 by 3 minus 8 power 1 by 3 by, here we have to get 3. To get 3 here, try to get 3. So multiply the numerator and denominator with 3 and add, and then add 8 to the denominator. So that 8 and 8 get cancelled. We get 3x in the denominator. To remove this 3, I am taking 3 here. Now both the limits are in the form x power n minus a power n by x minus a. As x goes to a, because as x is nearing to 0, x plus 4 goes to 4 itself. Here 3x plus 8 goes to 8 itself. So both are taking the formula as x power n minus a power n by x minus a, as limit x goes to a itself. Here x is 4 plus x, a is 4, n is 1 by 2. Similarly, here instead of x, here we have 8 plus 3x and a is 8. So that by this formula, n into a power n minus 1, by this formula you can write n is 1 by 2, a is 4 power 1 by 2 minus 1. This is the formula. This is the limit of this one, minus 3 into, because 3 is a constant. By this formula, this is 1 by 3 into 8 power 1 by 3 minus 1. On simplification, we get the required limit as a finite value. So that on simplification, that is 1 by 2, 4 power minus 1 by 2 here, minus 3 cancel, 8 power minus 2 by 3 here. That is 1 by 2 into 2 square whole power minus 1 by 2, 2 cube whole power minus 2 by 3. 4 may be written as 2 square, 8 may be written as 2 cube. These 2 cancel, 2 power minus 1. 2 power minus 1 is 1 by 2. Minus here 2 power minus 2, 1 by 2 square. 1 by 2 square minus 1 by 2 square, 0. 0 is also a finite value. Hence the required limit is 0. It's not 0 by 0 form. Actually it takes 0 by 0 form. To avoid that indeterminate form, just we are adding 2 and subtracting 2 to the numerator and rearranging the terms and bringing the total limit to this form, to this formula, limit as x goes to a, x power n minus a power n by x minus a form, which gives us n into a power n minus 1. That is the manipulation here. So you have to observe the given limit and how to avoid and think how to avoid that indeterminate form by suitable transformations or suitable changes to the function, and how to bring the known formula. That is the third process that we have to evaluate in dealing these limits. Next one, next problem. Limit as x goes to 5, x power k minus 5 power k by x minus 5 is 500. Then positive integral value of k. Then positive integer or integral, one and the same. positive integral value of k is. If limit as x goes to 5, x power k minus 5 power k by x minus 5 equal to 500, then positive integral value of k. This is very simple. This is clearly straight away as if the formula x power n minus a power n by x minus a as x goes to e. So by known formula, this is k into, instead of n, here we have k into a 5 power k minus 1, n minus 1. N minus 1 is k minus 1, here is 500. So that k into 5 power k minus 1 takes the value 500. Now you have to check for what value, for what positive integer value, for what positive integer value of k we get 500. Check by taking k equal to 1, 2, 3 like that. Check for which value of k we get 500. Clearly, once you take 250, 4 into 4 and 25, 125 into 4. Okay. So clearly, taking k equal to 4, you get this value, because k, once k equal to 4, 4 into 5 cube, 4 into 125, that gives us 500. Hence the value of k is 4. By observation, you can take k as 4. By observation, you can take k as 4.